Okay, cool. Let's now um hmm, hmm. I wonder. Okay, so I want to um so silly. Sure, why not? Okay, so the let me pop out chat. Okay, let me figure that out. Okay, let me figure that out. Okay, let me. Okay, I wonder. I should probably stop monitoring things. Monitor only. Okay, hopefully it's. Yeah, I just don't think that's gonna work. I think. Okay, yeah. Yeah. Okay, I think we're fine. Yeah. Okay, I think we're fine. Yeah. All right, we'll go with that. I think so. I'll pop the chat out, but make it hella small, hella small. Okay, so all right, what am I trying to do? So one thing that I thought about was yeah. So I want to I want to figure out like what are important or what might be like interesting things to be including in this paper. So it might be helpful to. I'm still gonna look at like my syllabi, but I also want to think about what the research has to say on like what are the important topics to be learning in a quantum class. Um, so I want to provide So there's, okay, I'm just gonna hide this the whole time. Um, Quantum mechanics formalism and postulate survey. Assesses student concepts, understanding of the formalism and postulates rather than mathematical skills. This is interesting. Hmm. I wonder if I have an email and password. Um, okay, that's all my information. Oh, are you kidding me? I need to. Can I find this as a free source somewhere else? Let's see. This will be fun. Okay, I want the survey. I would like the survey without having to make an AAPT account. If that were possible. Yay! Okay, cool. So here's the survey is provided on the supplemental resources. The average score for graduate students 5010. Ooh. Damn, 52% is not too great. There is a significant difference between the scores of students who use research-based learning methods and those who did not. This difference is the students benefit from research-based. Okay, yeah. Okay, cool. Um, I wonder. Okay, so I have this. It'll be let's try to think more about. Let's try to think. Okay, well first I want to Here's a link to a survey based on so this is testing like postulates and formalism. So and then I can provide the link for okay. So there's that. Oh, what happened to this one? Oh, that's why. What happened here? Put you back in. I want you in the middle. I want. Ah, fucking. Where's my. Okay, there we go. Okay, so here's a survey. So I want this link. No, I want just the assessments. Okay, so that's really cool. I want to see what they thought were direct notation, Hilbert space, state vectors, physical observables, and their quantum measurement, time dependence, expectation value, spin. Okay, that's a lot. Okay. Um, yeah, I wanna put this in Zotero. So we'll put this in Zotero. That'll make it easier for us to take notes on articles like this. Um, I'll add a new file, quantum text reading. Cool, so I want that in my quantum text reading. And I hope it gets a name. Yeah, okay, cool. Why is this fucking... It's so finicky. I hate how fucking finicky it's being, but whatever. Okay. Okay. Um. Oh, Jesus Christ. Okie dokie. So, um, I mean, considering where's my quantum syllabus? Foundations. We really only got to um like central potentials and hydrogen atom, I feel like in the first, but this is helpful. Um because I don't think we got to Hartree-Fock variational methods or density functional theory. We did a lot of perturbation and semi-classical methods. Um, partial asymptotic analysis, special functions, postulates. Okay. Hmm. Okay. Let's make a note. We'll make a note and I'll link it to. So I want to think about what needs to be included. And I'm thinking there's like, it seems like there's this important emphasis on like obviously postulates. I feel like the thing about quantum a lot of the time is you kind of forget how the postulates are always kind of at play when you're solving these like larger calculations. And the postulates aren't that um like that crazy, but they're still important. And I know that we can probably take postulates from Cohen Tamuji or McIntyre, if I could spell his name right. Who else would um yeah, so there might be other sources that I can think about that would kind of get at thinking about the postulates a little bit more. Um, so definitely postulates. There's also like math preliminaries, like kind of outlining the important mathematical structure, like at least for me, asymptotic analysis, like I know this was a big struggle. Yeah, so I know this was like a brand new topic that got used pretty um yeah, so that was like a brand new topic that really kind of got like introduced to me like as a consequence of like like approximation methods, which is a thing that should be included. Um, I mean, I think also PDEs, but mainly special functions is probably going to be pretty helpful. Yeah, so probably special functions. Um, what else? I think complex analysis is something that really need to mention or talk about as well. I think it's really important. Um, complex analysis, PDEs, but really special functions, asymptotic analysis. Um, I know group theory is important, but I don't. I think if I'm trying to have this focused on quantum, at least I rarely used group theory. Um, oh my god, I forgot to start the timer. Cool. Okay. So, oops, my bad. Yeah, so I know like yeah, thinking about the like we rarely use group theory. I'm sure um group theory is like a maybe, cuz to be perfectly honest, like I don't really know how we might have used group theory in my course, so we will see. So, let me take this and have it go here. And maybe take this and have it go here. Yeah. I mean, postulates are really important, I know. So yeah, postulates and any math. And unless, like, I'm wondering what they mean by formalism, so I might have to think about that more. I mean, I think step potentials, I think, are easy and they offer like some interesting things. Um, could also include Messia. Messia is really cool for the um, like what are the problems in quantum mechanics? There's like step potentials, like the ones that you do like an intro quantum class. It's like step potentials, um, central potentials. So like step potentials, central potentials are like the different problems you would use, or like the different like standard type of problems that might get analyzed. Free particle, harmonic oscillator. Yeah, okay. Free particle. Yeah, that's a good one. Harmonic. The harmonic oscillator. Yeah, periodic potentials. I don't know what random potential means. Yeah. Okay, so these were at least like the types of problems that got solved. Um, in my course. Okay, so then, so there's really like, there's like this class of exactly solvable systems that would be, um, so yeah, this class of like exactly solvable systems in quantum. Why can I not? Hello, why are you not letting me? Weird. Obsidian, why? Yeah, why are you being a weirdo like that? So yeah, there's this like notion of systems that are exactly solvable, like step potential, central potentials, the free particle, harmonic oscillator, periodic potentials. What are some other ones? Hmm. Scattering. No. Hmm. Okay, Hmm. That was Okay, here's what I was probably looking for. Two-state quantum systems, delta potential, so different. Hmm. Hmm. Interesting. So, I mean, delta potential is another one. I can't believe I forgot the delta potential because that's the one in undergrad that I had like I was like the most annoyed at. So some sort of delta potential. Okay, I think this goes into step potentials. I guess this is included in step potentials, really. Like, it's not, I mean, I would, I think at least like when we learned it, we were thinking about it as, it was like in this chapter where we talked about step potentials. Particle in a box. I feel like that also, so we got free particle, delta potential. I think that's that. Particle in a ring is interesting. Spherically symmetric potential. Is that not a central potential? It is. Okay. Harmonic oscillator. Yeah, particle in a box, lattice, periodic potentials, particle of one-dimensional lattice of finite length. Okay. Morse potential. Interesting. I might want to look into that. I'm gonna I'm gonna link the Wikipedia page. Yeah, there we are. Cool. So exactly solvable. Okay, so we got some exactly solvable systems. Keep the link there. Potential well. What are the chapter sections? Potential well, step potential, barrier, delta, harmonic oscillator, particle in a box. Okay, that doesn't even have. Yeah, this is getting like super symmetry with, yeah, with like the creation and annihilation operators. Like, that's cool. Like, I'll put this here just because. That's weird. What the fuck? That's so weird. That's really cool though. What the fuck? Okay, I'll just let this kind of be off in the ether. Because that's kind of cool. Um, but yeah, but there's like some math prelims, and then like getting into how to solve systems. I guess like what we're kind of gonna get is like different formulations of quantum. I think I think an important thing to kind of reconsider is like what the fuck is a wave function? Like actually kind of considering like providing some like historical insight or different like perspectives. Hmm. What do we want to listen to? Cute. Okay. Ooh. I think that's there's like a ton of stuff here. There's like perturbation theories. Um Classical limits or like classical approximations. There's like variational methods. So yeah, there's like classical approximations, variational methods. Um, yeah. Okay. So there's hmm. I mean, I'm sure there's more like approximation methods. Like there's like I don't even really remember talking about these. Hmm. Oh, Slater determinant has to do with like ah. Okay, that's a big thing. like spin, like stuff to do with like particle statistics. Yeah, and I feel like that kind of gets into thinking about like bosons and fermions. Bosons and fermions. Yeah, I can't think off the top of my head like what like what that would involve. But that is definitely something we should be thinking about. We fucking didn't talk about quantum info or fidelity at all, which blows. Yeah, I guess this idea of like entanglement. Okay, yeah, I don't know why this is here anymore. Let's just get rid of you. These like entanglement, particle statistics, like bosons and fermions. I think interpretations would be cool. Like philosophical interpretations of the formalism. So there's like systems, postulates, formulations. I mean, I guess I really just need to make sure like that this is like randomly off in the ether, like somewhere over here. Because really what's more on the quantum topic specifically is like scattering. I feel like I could just lump this into there. They're kind of related. Scattering? I mean, this could be an opportunity to talk about like Green's functions, if so desired. Let me make this red as well, because I didn't know if I wanted to include it or not. Yeah, I think the approximations part is probably pretty important. I think scattering is important. We didn't talk about it, but I would love to talk about quantum info if I can find a good source. But yeah, I don't know if I can find a good enough source on that. Let me get rid of this other stuff. We'll go to projects. Create. So I wanted to rename the canvas topics planning. Start planning topics. So I have started planning topics. It's in the topics planning section. So I don't really know. I could think about, I mean, I think where you would want to start, well first let me actually move the file to canvases. So I think, what else is there? Like what does Landau cover? Because that feels like it's... Oh. Ooh. Collisions, inelastic. Theory of symmetries might be interesting. The diatomic molecule is not something we might have done. Spin and spinners, like specifically spinners. Okay, I think spin, spinners, especially, would be cool. Bosons and fermions slash identical particles slash particle statistics. Yeah, so spinners, entanglement. Does entanglement get talked about? No. What other textbook do I have that talks about something? Sakurai. So he talks about fundamental concepts and Angular momentum, some group theory, central potentials. Hmm. Yeah. What was an interest? Yeah. Tensors, maybe. Symmetry. I mean, that's a whole. Yeah, I mean, that's a whole thing. Symmetries. Like, I know that's it's very broad. Um, so that might not. Yeah, it's very broad, but Sakurai has like a whole chapter on it, so it might be important or helpful or useful. And Shankar, let's see what Shankar's got going on. Okay, he also has postulates. And one-dimensional problems. Spin, scattering, speed, collision, path integrals, perturbation theory, symmetries, systems with n particles. Okay, this seems. Fuck, why'd I do that? Okay, that seems like I covered all of that stuff too. So I feel like this is the main, like, bread and butter, like, the main bread and butter, like, big topics. And then, like, within each, like, I feel like these are section headings or chapter headings or something like that. Because then I'll be able to, ooh, okay, hold on, I'm gonna edit something real quick. Cool. We're at the 1 hour mark. Yippee. 1 hour down. Who knows how many left to go? But it's about the journey, not the destination. But okay. But I think if I can find relevant, I want to go to a file. So I wanted to plan some topics out. So plan some topics. To consider looking at different concept inventories for physics, for quantum. Quantum concept inventories. To make sure I cover things that seem to be important. To quantum classes. Figure out an initial structure for what topics should be included. Okay, I'm definitely doing that right now. So I've looked through graduate syllabi. I'll take a look at the undergraduate syllabi. Um, yeah, I'm definitely doing this right now. I think this is also interesting. Um, I had a thought about creating a similar system to Knight's concept boxes or strategy or tactics boxes. Some topics in quantum mechanics. I think it would be helpful because I get to I'd be forced to find to look for underlying patterns and concepts when trying to solve different quantum mechanical problems. I don't know, I really don't know how well it'll work for other things. Yeah, so I think it really helps um, for like central potentials, harmonic oscillators, step potentials, because they're all um, they're 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 topics where you're not doing anything but just trying to solve for the wave function of a system. Um, and you can go about that in different ways. So it might be, you could have for each type of formulation. Like, so a tactics box would be different whether you decided to take like a Feynman path integral method versus like a matrix mechanics method versus like a wave function method. Might be an interesting avenue to kind of think about, or at least like maybe self-organizing in a way, or not self-organizing, but like organizing or having categories for tactics boxes that kind of like are built upon the ways that people kind of interpret these problems. Um, so tactics boxes that all kind of relate to or like matrix mechanics approach, maybe share some similarities versus those that are more of the wave functiony approach, might be interesting to consider. I'd have to think about that more. I guess wave mechanics. I keep saying wave function, but I mean wave mechanics. Yeah. Hmm. Okay. I feel like I want to start, but I also don't want to start. So I've definitely thought roughly about structure for things, so I'll check that off. But I wanna make a to-do that's more specific. So when I think about chapter or section slash section structure, do I want to have? I really like summaries. Ooh, okay. I should make a template. So I want in-text examples. I want summary at the end of a section. Tactics boxes, maybe? What else do I want? What else do I like in textbooks? Like, what's my favorite textbook? I like Taylor. I like Taylor. And I like Griffiths. I like Griffiths. I like Knight. I love Knight. I like the structure of Schwinger. Did I already pick Taylor? I like Taylor. I like Zengwell. I think Cattell. When I thought about like summary sections, I thought about Cattell. Yeah. I think this is interesting. What do I like about Knight? Mr. Randall. Let's pick, he has notes. He has stop and thanks. Ooh. Stop to thanks would be cool. So he's got an in this chapter and oh, I really like how this is laid out too. Key findings, laws, models, tools. Damn. Like, this is kind of just like everything you need to be able to understand what was going on in this section. Knight and Cattell. In-text summary, or in-text examples, I feel like Sangwell, Knight. Griffiths. Tactics boxes are obviously Knight. Stop and thinks are obviously Knight. I feel like I'm just taking a lot of shit from Knight, but I think Knight's my favorite textbook. I wonder if Stewart. I like Stewart too. I'm interested. Stuff's highlighted. Examples with solutions. Examples with solutions. Lots of figures, solutions, examples, exercises. What does stuff look like at the end of the chapter? Okay, maybe this chapter wasn't the best one to pick. What if I... So he's got problems, review, concept check. Okay, so he has the concept checks like at the ends of the section. Even after the exercises. Because the exercises are per section. And the concept checks are at the very end. I don't like that the concept checks are... I guess it's in the same spot. So maybe it's not that bad. It's probably fine. Yeah, they still have true, false, and concept checks. That's... Okay, Stewart also kind of... Stewart also seems like yeah, they do it. Hmm. Hmm. Hmm.
The purpose of this slide deck is to provide foundational intuitions for studying Jeremy England's recent paper, Statistical Physics of Self-Replication.
Damn. Okay. That's cool. That's pretty cool. Hmm. This is really cool. Significance is cool. Check your understanding. Ooh. This is so cool. Hmm. Yeah, this is that's really helpful to think about. Like, don't worry if I'm doing it wrong, not doing it good enough. Just worry about doing it in a way that I'm happy about, and doing it in a way that makes me happy, and um, and using those new experiences that I get, or that like struggle of not explaining something correctly or whatnot to kind of like drive my writing, um, and and influence what I have to say about a specific topic or something of that nature. Yeah. Okay. That's it's a that's such a good way to phrase it. This writing is a biography of my that's I really like the way of phrasing that. Like this is my story of how I learned this stuff and explained this stuff, and how I'm still ever evolving with it and trying to articulate this idea that like there's always going to be like this other step of me being able to learn something more about the topic. I think that's super cool. I don't know if I want to talk about. Yeah, okay. I'm happy with today. I think I'm... Oh, someone followed me. Thank you so much. You're probably not here, but appreciate the follow anyways. That's awesome. That's super cool. But yeah, I'm pretty happy with how good I feel right now, and the my mindset going into this. Um, and I understand that the mindset will probably dwindle a little bit, but I think I'm I need to make sure that I'm finding this nice balance of not trying to like rabbit hole on too many things, um, but also providing enough information. I do want to. I need to read this document. That's another. Read the Marshman paper on there. Yeah, I want to read this Marshman paper about the conceptual survey, to start basing my writing on the postulates and the formalism around. Okay, yeah, I think I'm gonna be done though for the night. It's getting kind of late, and I'm gonna just don't want to jump head first into craziness and burn out real quick. So I'm gonna head off. Bye bye.